Okay, so what is the highest common factor? Let us consider one example. Okay, let's see an example. Okay, so let's consider the factors of 18 and 24. Okay, so 18. So 18 we have 1 times 18, right? Then we have 2 times 9, right? We have 3 times 6, right? So this is the factors of 18. So we have 1, we have 2, we have 3, we have 6, we have 9, we have 18, right? Okay, how about 24? 24, we have 1 times 24. So we have 2 times 12, right? So we have 3 times 8, right? What else? Do we have 4? 4 times 6, right? Any more? Not right. So how many factors we have? We have 1, we have 2, we have 3, we have 4, we have 6, we have 8, we have 12, some more, 24 itself, right? Okay, so from here we can see that, right? Okay, we can find out something, right? Okay, so we can see. So we can see 1, 2, 3, and 6, right? 1, 2, 3, 6, right? Okay, so the other common factor of 18 and 24, right? Is it correct? Just look at here. Right. Okay, so they are the common factors. The common factors of 18 and 24. Okay, so let's consider explore. Okay, inside this 1, 2, 3, 4. So 6 is the what? 6 is the largest. Okay, is the largest common factor. Okay, 6 is the largest common factor. Okay, so in this case, we call the 6 is the highest common factor of these two numbers. Okay, 18 and 24. So we give a name, right? Okay, so 6. So therefore, 6 is the highest common factor, or we call HCF of 18 and 24. Okay, let's remember this. Okay, now we give the definition for this highest common factor, HCF. Okay, how we call that? We call that is the highest common factor, HCF of two or more positive whole numbers is the largest positive integer that divides the numbers without a remainder. Okay, without a remainder. So in this case, 6 is the highest common factor, HCF of these two numbers, 18 and 24. Okay. Sometimes we also call the highest common factor. We have another name. It's also known as the greatest common divisor. Okay, greatest common divisor. Okay, or GCD. Okay, sometimes we also call this name. Okay, just remember this. Okay, so in this case, okay, so now we know the definition of these highest common factors. Okay, let's move on to say, okay, so how to find out next question is how to find out the HCF. So there's many methods, many ways to find out the HCF, highest common factor of the two or more numbers. Okay, we can use, but basically because we already learned how to do the prime factorization, so basically we use the prime factorizations to find their HCF in a more effective way. So we use the prime factorization. So that is the most effective way. Okay. So in this case, we will use the prime factorization. Okay, we'll use this method. Okay, to find out the HCF. Okay, because this is one of the most effective way. Okay, now let us give some example, right? Okay, the first example. So find the HCF, the highest common factor of 225 and 750. Okay, so basically, okay, in this case, so basically we have two ways. Just now we see use the prime factorizations to find a way, right? Okay, let's use the first one. Okay. Okay, prime. Okay, so how we use that? Okay, we can use the vector tree, right? Okay, so 2 to 5. How we find 2 to 5? Okay, so we also recall that. Okay, so if a number, so all its digit is a sum of the sum is divisible by 3, so they also can be divided by 3, right? So 2 plus 5 equal to 9, right? So in this case here, can we put 3? Then we get a result what? 7 and 5, right? The next one is what? Can we put a 5? Can we put another? Okay, we'll put another 3. So 2, 5, right? So continue. 5 and then 5. Okay, so what is the prime factor for this? 2 to 5. 2 to 5 equals to 3 times 3 times 5 times 5. So we got this 3 square plus 5 square, right? Okay, let's continue another one. So okay, so another one is the second one is the same thing, factor 3. Okay, so same thing. Okay, so is that divided by 3, right? 3 as well, right? So 3. Okay, much 2, 5, 0, right? Okay, next one. Is it divided by 5 as well? Can we divide by 2? Or maybe we put 10, 25. Got 2 here, we got 5 here, we got 5 and 5. So in this case, let's divide by this 2. Okay. So in this case, how much we get? 750 equals to what? Equals to 2 times 3 times 5 times 5 times 5, right? 2 here, 3 here, and 3 5s here. Okay, so we get how much? 2 times 3 times 5 square. Okay, so let's compare these two. Okay, let's put them together. Okay, how to put them together? Let's put them together to visualize how can we compare these things. So okay, maybe we can put them together. 2 to 5 equals to 3 times 3 just compare these two. Okay, so let's remove it. Okay, so in this case, how many common factors they have? So we have 3, we have 5, we have 5, right? So these two count, we don't have this common. So in this case, so what is the common? Therefore, the highest common factor is 3 times 5 times 5 equal to how much? Is that 75? Okay, and we also notice that, okay, so it's 3 times 5 square. Okay, because here you got 5, right? Okay, so here we can see that, okay, so basically in this case, okay, so the HCF is able to obtain by multiplying the lowest power, okay. For instance, this number, so in the tree, the lowest power is 1, right? 1, okay? And then this 5, the lowest power is 2. It's 2 here, right? It's a 2 here, right? So the lowest power of each common prime factors, which is 3 and 5. So that's of the given two numbers. So in this case, surely, okay, we'll see here the lowest power, the common factor, this is 2, the 3, 750 have 3, right? 225 have a 3 as well. What's the lowest power? The lowest power is 1, so we take the 1. Okay, so for 5 is the common factor. So 5, what's the lowest power? The lowest power is 2, right? In this case, we take 2, okay? So we also can get a result is 75. Okay, is that clear? Alright, okay. Basically, okay, we also have an alternative method to resolve this question. Okay, now here we're using the prime factorizations based on the factor trees. We can resolve this question, right? So now we use the alternative method. Okay, let's look at how to resolve in the alternative method. So what is the alternative method? Alternative method. Okay. Successive short successive division. Okay. So how we do? Okay. We'll put these two together. 2, 2, 5 and 7, 5, 0. Okay, so what we get? So can we put the common? So basically all of factors, all of digits, out of the, this is 9, this is 12. Okay, so in this case you can put 3, right? How much we get? 7, 5, right? So this one 2, 7, 0, right? Sorry, 2, 2. How much we get? This is 2, 6, 1, 5. Okay, 5, 0, right? Okay, here, how about here? 5, right? What we get? We'll get 1, 3, 1. This is the 1, 5, 25, 5. Here, how much we get? 5, 50, right? So another 5. Here is how much? It's a 3. And how about this one? So it's 10, right? So it's no more already. Okay, there's no common factor. So in this case, the HCF equals to what? The common factors. We just multiply all the common factors. So together, in this case, the HCF is the product of all the divisors. Okay, it's product of all the divisors. In this case, is what? 3 times 5 times 5 equals to 75. We get the same answer, right? Okay, this is the alternative method. Okay, that's good, right? Okay.